In this, we are going to learn about the relation between the perpendicular drawn from the center to the chord. That is, the relation between the chord and the perpendicular drawn from the center of the circle. So we have the figure, and the theorem 1 states that the perpendicular from the center of a circle to a chord bisects the chord. So we have been given the center of the circle as O, and the chord of the circle is PQ. So according to the theorem, perpendicular drawn, that is OM, from the center of the circle of the chord should bisect the chord, that is it will be bisecting the chord PQ. So it says that if OM is perpendicular to PQ, that is, if it is given that, then accordingly we can say that it is bisecting the chord, that is PM is equal to MQ. So PM is equal to MQ. So this is what we have been given, that is OM is perpendicular to PQ, and this is what we have to prove. Now in order to prove, let us take the triangles, two triangles, that is triangle POM and the triangle QOM. So we are taking these two triangles. So we see that OP and OQ are the radius of the circle. So this is R and this is also R. So we can write that OP is equal to OQ being the radius. Now OM is the common side of both of these triangles. So OM being the common side, so OM is equal to OM. Then these are the right angle triangles. It is given that this is a perpendicular drawn to the chord. So angle OMP and angle OMQ is equal to 90 degrees. So we have proved that hypotenuse are equal of the triangles and one side is also equal. So we can say that these two triangles are congruent by RHS congruency rule. So the triangle POM is congruent to triangle QOM by RHS rule. So we can conclude that the corresponding angles and the corresponding sides of these two congruent triangles have to be equal. Therefore, PM is equal to QM. So we can conclude that the perpendicular drawn from the center of a circle to a chord bisects the chord. Now let us do another theorem, that is theorem 2, which is the reverse of the theorem first. The theorem 2 states that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So in this theorem, it is already given that PM is equal to MQ. That is, it has been given that it is bisecting the chord and we need to prove that it is perpendicular. So PM is equal to QM is given in this theorem. And what we need to prove here is that OM, that is the line drawn from the center to the chord, is perpendicular to the chord. That is, OM is perpendicular to PQ. So this is what we have to prove, and this statement is given. So let me take the similar triangles, that is triangle POM and the triangle QOM. So OP is equal to OQ being the radius of the circles. Then OM is equal to OM being the common side. And PM is equal to QM. In this theorem it is already given to us, that is PM is equal to QM. So with these three statements I can conclude that there are two triangles, that is triangle POM is congruent to triangle QOM by triple S rule. So they are congruent, therefore corresponding sides and corresponding angles will be equal since the triangles are congruent. Therefore the corresponding angles, that is the angle PMO or OMP, that is basically the angle M, is equal to angle OMQ. So these triangles are equal. Now PQ is a straight line, therefore angle OMP plus angle OMQ has to be equal to 180 degrees. Now since these angles are equal, therefore angle OMP is equal to 90 degrees. And this is equal to OMQ as well. So therefore, we can say that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Now let us do an example. The radius of the circle is 13 centimeters and the length of one of its chord is 10 centimeters. So we need to find the distance of the chord from the center. So this is the figure, and we have been given the radius of the circle as 13 centimeters, and we have been given the chord PQ, and the length of the PQ chord is 10 centimeters. And this is the line drawn from the center of the circle to the chord. According to the theorem that we just learned, OM should be perpendicular. OM is perpendicular to PQ, and therefore OM should bisect the line PQ, that is the chord PQ. Since OM is a perpendicular drawn to the chord PQ, and the theorem states that the OM should bisect the PQ. Therefore, accordingly, we can write that PM is equal to MQ or QM. So PQ is given to be 10 centimeters. Therefore, the length of PM is equal to 10 by 2, that is 5 centimeters. So now we have the length of PM as 5 centimeters, and we have the triangle OPM as a right angle triangle. So in right angled triangle OMP, OP square is equal to OM square plus PM square. That is the Pythagoras Theorem, as it is a right angle triangle. So we have the value of OP as 13. So 13 square is equal to OM square, that we have to find, that is the distance of the chord from the center, plus PM is given to be 5. So we can find the value of OM. So OM square is equal to 169 minus 25, and that is equal to 144. So OM is equal to 12 centimeters. So the distance of the chord from the center comes out to be 12 centimeters.